In this video, we will be discussing linear regression. This will be part 1 of the notes. There will be a second video to follow. Linear regression. Linear regression is taking data and our data is going to be bivariate data, x, y data, and creating a model. And by model I mean an equation and a line. We'll start with the equation, and of course with the equation we can generate a line. To predict y given some x. So we're going to take a scatter plot as we've seen previously and draw a line through it, a line that best fits it. And with that line we'll take an x value and predict some y value. Well, the form of regression we do most frequently in statistics is called the least square regression line, LSRL. This stands for least squares regression line. This is the most common regression model. And as the name indicates, the function of this line will be to make the squared errors, the differences between the points and the line, as little as possible. This line will always contain the point x bar, y bar. X bar, y bar, that's the average x, the average y, mean x and mean y. This makes perfect sense. This line is going to be essentially drawn through the center of our data, and this is the true center point, the average x and the average y, the point that's essentially most in the middle of our scatter plot. The equation of this line will be given by y hat equal a plus bx. This y hat is the predicted y value. A in this form, A is the y-intercept. You will be able to find A by taking y bar and subtracting off this b value, the slope, times x bar. So here you can see this x bar, y bar. A, it will be a function of the x bar, y bar, and this b value. Well, what is this b? Well, it's the slope. B is the slope. And just like in algebra, we know that slope is change in y over change in x. Well, this slope is given to us by r. This is what we studied last time, the correlation coefficient, times the standard deviation of y divided by the standard deviation of x. And so here you see that this concept of slope, change in y over change in x. Well, this r, the correlation, will give us the sign of the slope. If r is positive, the slope will be positive. If r is negative, the slope will be negative. So this value b is determined by these ingredients, R, the correlation coefficient, and the standard deviation of y and the standard deviation of x. In part 2 of the video, I will show you a couple of ways using we will use technology to find this least square regression line. Okay, we can use technology, and by technology I mean a Excel spreadsheet, a calculator, or a website to find this line. We can use technology to find the least squared regression line. All right. Now, once we have this least squared regression line, we'll be able to use it to take some x value and predict some y, but we shouldn't use it arbitrarily. We must first be aware of what's called extrapolation. Extrapolation is using the least squared regression line for values outside the domain. In the domain, what we mean by the domain are the x values that we have. We should only use extrapolation with extreme caution. It is often inappropriate. All right. Here's what I'm saying. Here's a sort of an obvious example. Let's say we were investigating the growth of humans. All right, from age 0 to 16. Okay, we might see some points that look something like this. All right, if we had many different children here. All right, it would definitely be a positive relationship. As your age increases, so does your height. Maybe this up here is 6 feet tall. Okay. Height in feet, age in years. Well, what the least squared regression model tries to do is draw some line. I'm drawing some line that best fits my data. The line might look something like this. All right, and that should be a straight line. And my line is probably shifted down a little bit. Again, in the next video, I will show how to use technology to use this. Well, this line is intended to be used for only values that we have, that is values from 0 to 16. It would be inappropriate to use this model for predicting at age 30, because as we know, at about 16 your height tends to level off and you're going to be this height for the rest of your life. If we extended this line all the way up to age 30, we might predict that you're going to be 12 foot tall. We know that's absurd. So bottom line, the least square regression model is only valid for values that we know, for x values that we have. We shouldn't use it in the future. And you see this all the time in the media. They will say something to the effect of, based on the amount of spending that we're having right now, that the deficit's going to be $100 trillion at the year 2050. Well, what they're not saying there, and what they should say, is if it continues at this rate. And that's the key thing. If it continues at this rate, and we don't know if it's going to continue at this rate. They haven't even decided what the budget's going to be for a couple years down the line, much less 20 years. So in this case here, we know for certain that you're not going to continue growing at this rate for the rest of your life. You're going to level off at some age close to 16. So extrapolation. We shouldn't use the model for values outside of what domain values we have. That concludes this video.